Hello everyone, and thank you for attending today's webinar, Navigating Rapid Shutdown Requirements When PV and Storage Are Present. I'm Kelly Pickerel, editor with Solar Power World. Before we begin, we wanted to let you know about our application widgets at the bottom of your screen. Slides are available to view at any time in the Resource widget, and please submit any questions related to today's webinar in the Q&A widget. We will try to answer these during the webcast. If we do not get to your question, our presenters may reach out to you afterwards. And finally, if you are watching this on demand, you can still use all of the features I have gone over. So let's get started with today's webinar, Navigating Rapid Shutdown Requirements When PV and Storage Are Present. I'd like to introduce our first speaker. It's Alan Santos-Buch. He is Western Region Sales and Marketing Manager of Sensata Technologies. Alan is an expert in solar and renewable applications with over 10 years of experience in technical sales, application support, and product training and seminars. He is a certified NAVSEP educator with an in-depth experience in battery-based backup, AC-coupled, and off-grid applications. And now, I'll turn it over to Alan and the Sensata team.
Thank you, Kelly, for that introduction. Today, we're going to talk about this agenda and learning objectives of our presentation. I'm going to introduce Ryan Stankevitz. I'm very pleased to have him join our team. We're going to talk about who we are, Magnum Energy as a brand, and Sensata Technologies, our parent company. We'll discuss important considerations for AC coupling before the advent of the Micro GT 500, our grid-type solution. We will discuss NEC compliance matters, specifically rapid shutdown as it applies to this kind of application for battery backup and grid-tied solutions. We'll introduce formally the Micro GT 500 and our storage-ready solution, and identify the essential loads to back up in the sub-panel, a very critical part of the application. Ryan, I'm very pleased to announce, has joined Sensata as a sales manager in the Northeast for renewables. He comes to us with 12 years of experience installing renewable energy, specializing in off-grid and energy storage devices. He has over 8 years of experience working with the manufacturer of renewable energy products, doing tech support, sales, and application engineering, that company being Midnight Solar. He is an extra class amateur radio operator. He's also a licensed master electrician, and he's active on many of the NEC code work groups. So we're very happy to have him on board the Sensata team. Magnum Energy today is a product brand of Sensata Technologies. Sensata Technologies, based in Attleboro, Massachusetts, is the United States headquarters, is formerly Texas Instruments Sensors and Controls. So we're very proud and happy to have a very resourceful parent company that is building out and dedicated to a renewable energy strategy and portfolio. So Magnum Energy's roots as battery-based and power conversion devices is based in 2211 West Casino Road in Everett, Washington. Our manufacturing facility has moved to White Bear Lake, Minnesota, where it's joined our sister company in the inverter business called Dimensions. So we've consolidated there and keeping here in Everett our engineering and sales and marketing teams. So how does Magnum Energy set itself apart from the competition? Well, Magnum is founded in Everett, Washington, is a product that's made here in the USA, now in White Bear Lake, Minnesota, where we consolidated our operations. We have authorized service centers throughout the country, including Canada, so customers can get their parts that they need if there are any repair issues. And we have up to 5-year warranties on all our battery-based devices, and the Micro GT 500 comes with a standard 25-year warranty. The inverter chargers we make are robust, low-frequency inverter chargers built to last. They can start inductive loads and provide AC to a load panel within 20 milliseconds, typically 16 milliseconds. A great after-sales support team and the most knowledgeable and accessible Magnum technicians, support technicians are available to analyze and troubleshoot your systems and even help you set up the programming of the remotes, which, by the way, are very intuitive and designed for the end user, very much like programming a car radio. It's the easiest remote to program in the industry. Most anyone will tell you that. So also the components are designed to put together by one person very easily. It's modular in design. The instruction manuals are very well written. We have 2 full-time authors, tech authors, that continually update our manuals and support material. As far as dependability goes, we focus on that very stringently. The boards are tested before going into production. During production, each unit is tested at least twice, burned in and charging, and the results are captured for every unit by serial number. So the incidence of DOAs are lessened. We're refocused on this move to White Bear Lake on quality and shorter lead time. So you'll see greater improvements going into the future. Sensata Technologies, our parent company, is one of the world's leading suppliers of sensing equipment. Sensata, which actually is Latin for the gift of sense, or those gifted with sense, is a company that's been around for 101 years, formerly known as Texas Instruments Sensors and Controls. It's now traded on the New York Stock Exchange and has roughly a $7.5 billion market cap. So the company, our parent company, provides great resources to us and is committed to building out the renewable energy portfolio for us. And our devices together improve safety and efficiency and comfort for millions of people every day. So we're a key player in these end markets, OEM markets, for automotive, for example, aircraft, telco, RV, and marine and renewables.
So part of the presentation today is about AC coupling. That's what the Micro GT does with the Magnum PAE. With that in mind, I wanted to back up and kind of give you a few bullet points on what we used to do in the AC coupling world. What I like to call the bang-bang charging, because it's basically on or off. And when it goes off, it has to wait 5 minutes to turn back on. So if you can picture it, it's kind of like all or nothing, kind of brute force and ignorance, if you will. With that in mind, one of the bullet points that I like to make is that there really hasn't been an off-the-shelf solution, so to speak. We've typically done blackout relays, relied on frequency shift. We've used some kind of relay driver to knock things offline. There's been a lot of home-brewed situations that work really well, but it does add liability. It does add time and money to the job. So with the Micro GT and the Magnum PAE, of course, that's all flawless, and it's done for you, and it's using the Magnum slope. Some of the ways we've done this, we've done blackout relays, and for those of you that aren't familiar with that term, a blackout relay is essentially just a 2-pole relay that would go in line with the 240 volts going to the grid tie inverter or microinverter, and something would trigger that relay. Like in the case of a Magnum system, we might use the contacts in the router to trigger that, or you may use a relay driver. Something would trigger that relay to open on battery voltage rise. So what we would normally do is set that trigger point to be around the absorbed voltage of the battery. But what happens is the battery voltage rises slowly, say it runs up to like 58.8, triggers that relay, then your grid tie inverter shuts off. And that battery voltage drops back down because the loads are sucking out of the battery, not off the grid tie inverters now. And at some point, that is going to turn the relay back on, but your grid tie inverter is going to wait 5 minutes to reconnect. So you get a pretty good sag in battery voltage, and then the grid tie inverter reconnects, battery voltage runs back up, and the process repeats. The big thing that I want to point out is you get no absorb time at all with this system. So with that scenario, you're going to get just an on and off charge of the battery, but it's not so much a charge of the battery as it is running the loads till the battery hits a set point and then it shuts off. The other thing we've done is frequency shift. In the past, we've had inverters at frequency shift, like the PAE, for instance, by Magnum. It does frequency shift, so if you're using somebody else's inverter, not the Micro GT, it will still knock them offline. The SMA and the Snyder both frequency shift, and they do the same thing. When the battery starts to get fully charged, they shift the frequency out of the UL window, which will then knock the grid tie inverter offline. But again, the unfortunate side effect of that is once the battery voltage drops down, that frequency will come back and stabilize at 60 hertz. But now we have to wait 5 minutes again for that grid tie inverter to reconnect. And again, just like the first example with the blackout relay, we don't get any absorb time. So these two are typically problematic because of the no absorb time. The other thing that I've seen happen in my past is I've seen big enough loads that the battery can actually sag in that 5-minute window enough to hit the low battery cutout on the battery-based inverter and shut the whole system down. So that's kind of a, it's the old way of doing it. We can be smarter than that. We have better technology, and we can do a flawless system that doesn't require you to do any, put any liability on the line, if you will. Plus, it's just included in the cost. There's no extra cost to do that. Another way we've seen this done is with AC or DC diversion loads, similar to if you've got a wind turbine in the system. You have to do something to use up that energy. One of the pluses to AC or DC diversion is it does give you 3-stage charging. But the downside is it adds complexity, danger, and cost. What I mean by that is, let's say you use an electric water heater for a diversion. If that water heater gets hot, it's going to shut off. Now you've lost your diversion. So now you have to have a secondary diversion that will come in. So there's some danger there. There's also a danger on sizing that correctly. If you used like a DC diversion load and you went back and expanded the system and didn't expand the diversion load, you could overload that diversion and possibly even catch it on fire. So there's a lot of liability, a lot of cost, and a lot of diligent fiddling, if you will, to be involved in that. So just some highlights on how we used to do AC coupling, the old way, if you will. That's kind of what it is. So one of the other things we wanted to talk about was NEC and rapid shutdown. And having spent a lot of time on some of these work groups, more than I like to keep track of sometimes, I'm pretty versed in the 2014 and 2017 NEC 690.12, but to really bring it down to what was intended, 2014 690.12, rapid shutdown, I'm sure you've all heard about it, it's probably a thorn in your side. The thing to remember with that is the very basics of that is we have a 10-foot boundary around the PV array. PV array is well defined in NEC, so we don't have to worry about that. But anything outside that 10-foot boundary has to be brought down to 30 volts within 30 seconds. Now that might be a surprise to some of you because 2014, the code book actually states 10 seconds, but that was amended with TIA 14-10. So you can do a Google search for that if you need to prove that to an AHJ. But just know that it was amended to be 30 seconds. It was deemed that no firefighter was ever going to be able to get on the roof, cut a hole through the PV array within 10 seconds, so they allowed us 30. That's the gist of it. There is a part there that says anything 5 feet long or longer inside a building must be controlled, and that's the one that gets us a little bit in the mischief with the AHJs, because a lot of them will try to interpret that as battery conductors, and unfortunately that's not the case. That was not the intention, let me say that. The intention of the code-making panel was to only apply this to the PV source circuits between the PV array and the first disconnect. Unfortunately, like I said, inspectors have to interpret NEC because 2014 really only put in about 4 sentences that have any meat to them, and it was not very well defined. But just know that's what it was intended for. If you get into mischief with the battery side of it, reach out to us. We can try to help you out with that. But basically, 2014 is going to require a listed product inside the 10-foot boundary that's controllable from the ground. Now, what that means in the case of like our microinverter is that it converts it to AC on the roof. So when you stop the AC to the building or you shut off the AC disconnect to the microinverters, they quit inverting and the lines go dead. So by default, they're going to match, take care of the 2014 for you. I think I got a slide here that, it's a little bit of an example of what this would look like physically. So the gray box here, the big box, is the roof of the structure as marked, and the tannish colored box is your 10-foot boundary. The thing to note about this is that you would be allowed 20 feet between the top and bottom row of PV modules. On a normal residential roof, that's not a problem, but if you get into more of a commercial building, you might have an air handler or something that you've got to get around, and if that conduit between those two modules gets to be 21 feet long, that conductor has to be controlled. So just make sure that doesn't catch you off guard. But as shown, you'd have a rapid shutdown compliant combiner box of some form on the roof. If it was a DC coupled system, you could, in theory, put a string inverter within 10 feet of the array. That's not usually very practical, but you could. And the goal is to control that black conductor coming out of the box of the combiner and bring that below 30 volts within 30 seconds, keeping in mind the capacitors on your inverters or charge controllers. So we'll go into 2017 a little bit. 2017 rapid shutdown is massively better defined. It's gone from, I think, 4 sentences to maybe like a couple hundred sentences. So again, I don't want to read the whole code book to you. What I really want to do is explain what changed, what happened between 2014 and 2017 that's going to affect you on a day-to-day basis. The first one is the boundary. 2014 allowed us 10 feet around the array. 2017, that has reduced it to 1 foot in any direction. So that's a very substantial change. Your device has to be within 1 foot of that array. You guys can't see my hands, but I'm picturing an array of my hands here. It has to be within 1 foot of that array in any direction. It is much more defined. It does try to do a better job of telling us that it is not to apply to the energy storage. It specifically calls out the PV source conductors, in the between that and the first disconnect. It also gives us 2 separate controlled zones. So this is new. 2014, anything inside the array boundary could be up to 600 volts in a residential application. And 2017, that is now going to be controlled as well. So I'll come back to that one in just a second. But the outside of that boundary, 1 foot of the array and further out, is still the same, 30 volts within 30 seconds. It just got brought into 1 foot of the array. Now, inside the array, what they have told us is they want less than 80 volts or less, within 10 seconds between any 2 conductors or any 1 conductor and ground. They don't call it module level shutdown, but the only way to comply is to disconnect every single module. The one thing they have done is they put in there that we have until January 1st of 2019 before that part of 690.12 takes effect. So until January 1st of 2019, only the 30 volts and the 1 foot boundary are in effect. After January 1st, or if your state doesn't adopt 2017 until, say, January 1st of 2020, then you would be exempt from that until 2020, obviously. But if you're like Massachusetts and you adopt on January 1st of the year of the code, then that portion of 690.12 does not get enforced until January 1st of 2019. Again, just to reiterate, it was never intended to apply to the battery portion of the system. Batteries and battery-based inverters like the Magnum PAE are a lot like an auto-start generator, and fire code has always relied on placarding to warn first responders of the dangers of any automated power system inside the building, like a generator or a battery-based inverter. So just keep that in mind. If the inspector does, really push on that, you can reach out to us. We can put you in touch with some of the code-making panel if that can help. And again, just like 2014, this is going to require a listed product inside that boundary that can be controlled from the ground. That's where the Micro GT really shines, because it qualifies all of that. Even if the inspector interprets the AC lines as DC for some reason and thinks he wants to see rapid shutdown, all you have to do is open the AC disconnect at the ground level, feeds the Micro GTs, and you've now shut down the whole system. You're less than 80 volts anywhere because you're a single module, and you've de-energized the conductors coming down the side of the building, so it's inherently easier for you to make a rapid shutdown compliant system. And here's a picture of what 2017 looks like. And you'll notice in the middle of the screen here it says 2 foot max. And that, again, becomes really important, because if you've got a skylight on a residential dwelling and you skip over that skylight, you're likely going to have more than 2 feet between those 2 modules. And that conductor would then be considered controlled to less than 80 volts. Less than 30 volts, I'm sorry. So that's something to be really aware of, because you have 80 volts inside the box, If you've got more than 2 feet between two modules, then it becomes considered a separate array, and you have to control that conductor.
Thanks, Ryan. That's a great explanation. The Micro GT 500 is our choice for these kinds of applications, and for several reasons that Ryan hit on. They're extremely safe by design out of the box. And with the evolving NEC standards meant to protect the homeowners and first responders, it's great to have a product that is at a low cost per watt and no additional componentry required unless the AHJ insists. But each unit in the micro inverter array performs its own rapid shutdown function in just 100 milliseconds. So this is a very, very fast result and against the specified standard of 10 seconds for shutdown. So system voltage at shutdown is about 30 volts DC, meeting stringent NEC requirements and well below the 80 volt threshold generally considered safe for contact. So we're going to talk about and get down into our Magnum products now with the Micro GT and the components required for this, system planning, the connections, design considerations, how the system works, the monitoring that's available, and in the end we'll summarize in the available materials that you can source to get this project going. Yes, there are very good reasons to use microinverters and with storage in an AC coupled application. We mentioned safety and NEC compliance. The microinverter has a greater harvest potential, and it mitigates shading. Obviously, with a string inverter, if the one panel is partially shaded, you lose most of the string and that potential power output. So module level performance monitoring, each inverter is monitored. It's a dual MPPT, so they act independently, 2 panels per microinverter. And with this system and this type of installation, you can add the energy storage right away with the design or with the installation or later. So if it's not in the budget, you can add the PA system very easily later on.
All right, so Alan pretty much covered, why we would use a microinverter with storage or a microinverter in general. I wanted to talk really quickly about why you'd use the Micro GT versus, say, another microinverter. One of the real advantages to the Micro GT is that it's very easy to add energy storage because of the interaction with the PAE battery-based inverter. Alan's talked about that on that a little bit more. But another one is the Micro GT itself. It's a 2-in-1 inverter, so it's a dual inverter with dual MPPT, meaning you can plug 2 modules into that, and it's a 500 watt AC microinverter. That one does cause some confusion. People think 500 watts and think they're limited to 500 DC watts, and that's not the case. You can put a 310 watt module on each side of it if you want. It's going to produce 500 watts AC. A couple of the other things that are really nice about the Micro GT is, the fact that it doesn't require a trunk cable. It's plug and play. It's daisy chained together. There's a simple end cap that terminates the end of the string. We do have an extension cable if you need to get around a skylight, and there's an AC whip that would take you to a junction box for your feed to the branch circuit. So it's just a real easy to install solution. No trunk cables. Like Alan pointed out, no single point of failures. The Micro GT comes with a 25-year warranty, and it is going to satisfy 2014 and 2017 NEC. So, again, introducing the Magnum storage ready microinverter and accessories. As I mentioned, probably already hit on all these, but there's no wires on this one for the slideshow here, but there would be 4 MC4 connectors hanging out of it and 2 AC pigtails, 1 short and 1 long. And you just keep daisy chaining these together to get up to 7 per branch circuit. You can do 7 of these on a 120 240 volt branch circuit, and they are 500 watts AC, as I mentioned. They do use PLC to talk to the MagWeb GT, which is the communications gateway, if you will. It is optional, but we do highly recommend that. And the cloud-based monitoring portion of this should be coming early in 2018. Currently, because the MagWeb GT actually incorporates the Magnum PAE 4448 or 4024. The cloud-based software is not quite done yet, but we do expect that early in 2018. This next slide. All right, so I'm not going to read this slide to you because it's basically an overview of everything we've talked about and things that we're going to continue to talk about. Just wanted to put this in here so that if you're downloading this presentation, you can really have all of the bullet points here. So at this point, I'm going to pass it over to Alan, and he's going to talk a little bit about the battery storage aspect of this.
Sure, thanks, Ryan. Yeah, as you probably all know, Magnum Energy's core competency is battery storage. Battery-based inverter chargers we've been designing for over 15 years. In fact, we're celebrating our 15th year anniversary this year. So, we're battery agnostic. We like to say we're also inverter agnostic in these systems. And just to recap, this slide is a summary so far of what we've discussed. Let's move on.
Here's a simple parts list. Here's the 4 parts that you would normally use in a micro GT system for just purely grid tie. Very simple. That parts list is also available online as a PDF. A couple key points I really want to hit on here. As we mentioned before, up to 7 inverters or 14 modules per string. The micro GT will support a 60 or a 72 cell module. So it's a single device for either 60 or 72 cell. And it's pointed out a couple times here, this is a daisy chain system, absolutely no trunk cable required. So real fast installation, not going to end up with a whole bunch of 1 or 2 socket trunk cables left over when you're done. Just plug the inverters together.
So this is a line diagram of a solution that's storage ready. Here we got the Magnum Micro GT 500 capable of backing up 4 kilowatts in the essential load panel. The key point here to make is if it's not in the budget immediately to add storage or the battery-based side of this application, you can remove the essential loads from the AC main panel and move to a sub-panel. And connected there would land the 4 kilowatt or less array to the essential loads panel. And later on, you can add the PA system in between the AC main and the sub-panel. If the array is larger than 4 kilowatts, sure, you can do that. You have to design in mind and keep in mind that you're backing up 4 kilowatts with this first iteration we have. And if the array is larger, the balance of that array can land in the AC main panel. If you lose power from the grid, obviously you're going to lose the part of the array that's connected to the main panel. But the array that's backing up the central loads will be active and synchronized with the output of the PAE in that sub-panel when it's added. So we'll move on to the next slide, please.
All right, so just a few bullet points here, how the two systems work together. Bullet point 1, the Magnum PAE inverter, you're going to set that up for custom battery. And when you put that in custom battery mode and you set those battery parameters per the battery manufacturer specifications, that automatically enables AC coupled mode internally. And what the Magnum does is as the battery voltage increases just past that set point, that absorbed set point, it's going to start lowering the frequency, which is what we're talking about in number 2. So the Micro GT is watching for that lower frequency, and as it starts to see that, it backs its power down. And we call that the Magnum slope. So as the PAE sees the battery voltage getting too high, it'll drop the AC frequency a little bit, and the Micro GT watches for that, and as that frequency drops, it curtails backwards a little bit and just basically throttles back. And it will keep throttling back all the way to 0 if needed to protect those batteries from overcharging. Without a system like this, or without something like we talked about earlier with the blackout relays, the battery voltage would keep climbing, and eventually you'd have meltdown on your batteries. Sometimes I've seen a couple systems where the customer has relied on loads to maintain that, and that's kind of scary because loads aren't always guaranteed. So this just is a real elegant solution engineered to work together. No real input by you. The only thing you have to do is enable custom battery mode. That's the most important thing I can mention here. And that automatically enters you into the Magnum slope system where we control the Micro GTs.
So previously in the line diagram, we showed you a storage-ready application design. Now the customer is going to add storage, and it's a very simple parts list. The Magnum 4448 PAE or the MS 4024 PAE can be added to the system for backup storage. And here it's easily inserted in between the AC main panel and the sub panel to provide that grid reference, frequency reference you need to the sub panel if the grid goes down. The inverter immediately inverts to that sub panel and provides that reference required to keep the microinverters up and running. So that will keep your essential loads going and obviously be a happy battery bank, as it can curtail its output as the battery voltage rises. The parts list is very simple. As I mentioned, you've got a back plate, the inverter, the breaker enclosure, the remote control, and an optional battery monitor kit, which we recommend.
So as Alan pointed out in the last slide, the part system is really simple. And on the left here, this is what it would look like all assembled. It's a pretty small package, easy to install, modular, available in a 4,000 watt 24 volt system or a 4,400 watt 48 volt system. Both of them provide 120/240 split phase as a reference for the micros. And as you see on the very right hand side, we recommend 3.5 to 4 kilowatts because we want you to stay just under the nameplate rating of the inverter so that we don't overload it as we're AC coupling. So if you're doing a 4024, we do a 3.5 kilowatt array. If you're doing a 4448, we'd say go with a 4 kilowatt array. And on the battery bank size, we recommend somewhere between 2 to 800 amp hours. If you go much more than 800 amp hours on a single PAE, the battery charger is not going to be quite sufficient enough to really desulfate those batteries if you need to. So that's just a general rule of thumb, but the battery size is usually going to be something that the system installer and the homeowner work together to appropriately size for the amount of backup that the customer wants. All right, so talking about optionally installed components, the ME-MGT-MW, or MagWeb GT, is your communications gateway. So even though we say it's optional, it's really pretty mandatory in my opinion because it gives you all of your logging, all your data. It's how we update firmware and anything, or we make changes if need be on the inverters. The one thing I want to point out really quickly is it does use PLC, Power Line Carrier Communications, and it does have one of the more robust power line carriers that I've seen in the industry. So it will work well. It does need to have a dedicated 120 volt receptacle out of the critical loads panel. Keep in mind that it does need to be fairly close to the Magnum PAE because it does plug into the router to collect all the battery stuff. Some of the big gotchas, like it says down bottom, with any PLC device, be it the MagWeb or any kind of monitoring system, don't plug it into a surge suppression strip. Don't plug it into a GFCI or an AFCI receptacle. That will diminish the PLC signal. So I'm going to show you a couple screenshots of the local. All right, so here's an example screenshot of what you see when you connect to the gateway, or the ECU, if you will, Energy Communication Unit. This is an actual shot of my system here in Maine. This is a beta test system for stacked PAEs in micro GTs. We are actively working towards supporting that, as Alan mentioned earlier. I'm not going to go into all the details you see here. Just realize that you're going to have access to these tabs up above, the home, the micro GT, and the battery system status. And that's what you're going to see all this information on each one of those tabs. And it's going to allow you to drill right down into each individual inverter if there's a concern of it. This one here is showing the battery side of the system, and this is pretty cool because it puts it all under one umbrella. Quick glance, you can see what the microinverters are doing. You can see the state of charge of the battery if you have the BMK installed, the current draw on the battery, etc., and any faults or anything on the inverter. Just all the information is right there. It's pretty cool. So to recap really quickly, why the micro GT and Magnum energy storage solution. And really, I think we've beat it pretty well, but safety, NEC compliance, ease of installation, savings on labor, no combiner boxes, no hassle with rapid shutdown, And one of my favorite ones, like I like to say, is happy batteries. You're actually going to do some absorb charging on the battery during an outage, so if it's an extended ice storm or something, you're going to take a little bit better care of those batteries, and they're going to treat you a little bit better. And the simple fact is it's all engineered to work together seamlessly. So you're not reinventing the wheel. You're not going to get a bunch of parts and figure out, how do these work together? I'm not able to figure this out, or I'm having these problems and I call one manufacturer and they point at the other one. You're calling a single manufacturer. You have access to tech support, engineering, and anything you need, and we will make sure that you've got it working as designed. So in closing here, I want to take a few minutes and just talk about loads that we're going to move to the backed up loads panel, or the essential loads panel, whatever you may refer to this panel as, but it's the one that's being powered by the 4448 or the 4024. Keeping in mind that the current Magnum system is good for about 4 kilowatts of backup, and we are working to expand that up to around 16 kilowatts of backup energy. Just keep that in mind as we go through this. But generally speaking, the more you move to that backed up loads panel, the more money you're going to spend on batteries and inverter. So a lot of times the customer will have some pretty big wants. If you ask a customer, what do you want to back up, they're always going to say the whole house. And then we take and we show them the number to do that, and then we work that down to a conservative essential system, if you will. What are the essential loads this customer needs? What are the customer's goals? Are they in a spot that loses power for a couple hours once a year? Are they at the end of a line in the middle of the woods in Maine where when an ice storm comes through, they're without power for a week? We start to balance things and say, okay, what are we looking for here? Typically speaking, we're looking for things like all the lights or a good portion of the lights, because lighting is usually a pretty small load if you're using conservative things like LED bulbs. We're looking for refrigeration. We don't want the freezer to thaw out. We don't want the refrigerator to thaw out. So we try to keep that stuff in mind. That's important. One of the things that a lot of people miss and don't always back up because they don't think they need it is like TV or maybe a circuit for radios or something. Personally, I think the TV is important because if it is a natural disaster, you're going to want news, or if it's an ice storm, you're going to want to watch the cartoons. So those things are all kind of key, and it's really important that the installer and the customer work together to come up with a realistic expectation of what the system is going to do based on what the customer wants to spend and what the customer's needs are. One of the things that I see come up a lot is the well pump. If you live in an environment that does not have city water, you're going to have a drilled well. You might have a submersible well pump or a deep well jet pump or whatever that case may be. You really want to consider that, because that's one of those things that if it is an extended outage, water is going to be a priority. And for most cases, most average well pumps, either one of the Magnum inverters, the 4024 or the 4448, will start those well pumps no problem at all. So that's definitely something to keep in mind, is backing up that well pump so you can have water. But other than that, just to recap, it really boils down to keep it down to the essential loads. Conservation saves you money, just like being off-grid. Look at your light bulbs. Try to convert to LED bulbs if you can. Get an Energy Star appliance like a refrigerator or a washing machine if that's going to be on there. That's the kind of thing you got to look at. So that really brings us to the end of the webinar, and I'm going to turn it back over to Kelly so we can do the questions and answers.
All right, we're going to open up the floor to some questions. Remember, you can continue to submit any questions at any time via the Q&A widget at the bottom of your screen. So our first question, will the Magnum PAE still work with other microinverters or string inverters?
Oh, thank you, Kelly. I'll take this one. Yes, the PAE will frequency shift in stages to control the output of our micro GT, but if the battery voltage should continue to rise, it will quickly drop that frequency down outside of the UL 1741 window, shutting down any grid tie inverter. So essentially, it will still work with an Enphase or an SMA or a Fronius or whatever brand you might use, but you're going to give up that regulated charging that we get using the Magnum slope with the micro GT and the PAE. You'll still protect from overcharge of the battery, but you won't get any regulation. Thus, your batteries won't be quite as happy. But if it's a retrofit, that would work just fine.
Okay. So if rapid shutdown wasn't intended to apply to the battery portion of Solar Plus Storage project, do we need to add signage to alert firefighters of the batteries?
That's a good question, and I am not a signage expert, but my research shows that NEC 706.11 has Part A and a Part B. Part A is for grid-connected or interconnected homes. Part B is for standalone or off-grid homes. And basically it's saying that a plaque or directory denoting all power sources shall be installed at each service entrance equipment location on a grid-connected home. And on an off-grid home, it's basically telling us that there needs to be a plaque or directory on the exterior of the building in a location likely to be seen by first responders, and that is also acceptable to the AHJ, or authority having jurisdiction. The plaque or directory must also indicate the location of the system disconnecting means and that the system contains a standalone power system.
Okay. You said that the Micro GT, it's 2017 compliant. It's not just 2014 compliant?
Yeah, that's a good question. And 2017 and 2014, the real difference is when we're talking rapid shutdown. 2014 asks us to shut the array down such that conductors leaving the array are de-energized, but the array itself can still be up to 600 volts DC. 2017 is asking us to shut down each module individually so that we do not measure more than 80 volts anywhere inside the array. And both 2014 and 2017 give us 10 seconds to do that. By default, rapid shutdown doesn't really apply to a microinverter because the microinverter is AC. The conductors leaving the array to the ground would be AC, not DC. Thus, they don't really fall into the rapid shutdown category. But in my experience, I've seen a lot of inspectors interpret those conductors to be, they want to see them controlled still. So knowing all of that, knowing that the arc fault requirements are 80 volts or above DC, yes, the 2014 and 2017 NEC would be completely satisfied by our Micro GT.
Okay, perfect. What battery chemistries can your solar storage setup work with?
Hi, Kelly. Thanks. I'll take this one. This is Alan. We'd like to say that the PAE and all of our inverter chargers are battery agnostic. So we work with any type of battery chemistry, including Acheon and lithium-ion batteries. So flooded lead-acid batteries are typically used in off-grid applications, and the AGM, or absorbed glass mat, is used typically in backup scenarios. The AGM has a long shelf life. It can stay at a steady charge for a long length of time and ready to go and go to work when there's a grid outage. So to answer that question, nominal, 48-volt systems or 24 with the PAE. There are two models. The 4024 and the 4448 will work with any battery chemistry.
Okay.
Thank you.
So does the Micro GT have rapid shutdown built in, or does it still require a disconnect switch at ground level?
I'll grab this one, Kelly, because it sort of applies to the question 3. Similar to what we talked about a couple questions ago, the Micro GT is basically an AC. It produces AC outside the inverter, so it doesn't really qualify for rapid shutdown, if you will. But again, as I mentioned before, some inspectors do still consider that and want to see a initiator, if you will, or a disconnect. But to go back to the question of the disconnect, there is no specific requirement for one, but most every utility company and most every AHJ, authority having jurisdiction I've ever run into, will require a lockable disconnect on the exterior of the building for the grid tie system. So if the inspector is asking for a rapid shutdown disconnect, then you would placard that to meet that demand for him. But the simple answer is it does not really have to comply to rapid shutdown because it's AC coming down off the roof, not DC.
All right, thank you. All right, that's all the time we have for questions today. If you have additional questions or we didn't get to yours, feel free to contact our presenters on your own. This webinar will be shared with all registrants, so you can view it again at your convenience. I'd like to thank Alan and Ryan again for being here, and Sensata for sponsoring today's webinar. Thank you to everyone in our audience for participating, and I hope you enjoyed our presentation. We invite you to join us for more Solar Power World webinars in the future. Thanks, everyone.